Hey guys, this is Miss Bufford, and in this video, we're going to talk about balancing half reactions. So your learning goals here are to be able to write and balance half reactions in neutral conditions. And so these are all redox reactions. If you look up other help videos on the internet, that's okay to do. Just be aware that you want to avoid watching the ones that are in acidic solution or basic solution. See if you can find one that occurs in neutral conditions or that we're just balancing for charge. All right, what are half reactions? So together, oxidation and reduction describe the transfer of electrons from one chemical species to another during a chemical reaction. Because of this, they cannot occur alone, meaning that if something is oxidized, it loses electrons. Something else will have to be reduced when it gains those electrons, because those electrons must have somewhere to go. Sometimes it's useful to write the reactions for oxidation and reduction separately in order to balance the charges. We call these half reactions because they only describe half of a redox reaction. When we balance these, we're balancing them for charge, and we're using electrons to do that. And so I'm going to go ahead and point a couple things out about these two half reactions over here. We've got the oxidation half reaction. Notice that the electrons that were added to this equation were added to the product side. And then for the reduction half reaction, the electrons that were added in here were added to the reactant side. So you just want to keep those in mind for a minute. And the reason for that is that oxidation, if we remember, oxidation is the loss of electrons. So what we're describing here is this zinc metal losing 2 electrons and becoming a zinc plus 2 ion and 2 separate electrons. Then the other side of this reaction where those electrons are going is we've got copper 2 ions that were in solution gaining 2 electrons and becoming neutral copper atoms. All right, so the oxidation half describes the electrons going out, and the reduction half describes the electrons coming into a substance. All right, so let's go ahead and take a look at a couple of examples. So this first reaction, I did go ahead and list some steps over here, but the first step that I started with was to identify the species being oxidized and the one being reduced. And in order to do that, we have to do what we did in our last video, which is assign oxidation numbers to all of the elements in this reaction, and then look for the changes. So what I'm going to do is I'm going to go ahead through and I'm going to assign oxidation numbers. And remember, I'm just using those rules that we talked about. There is a rule for sodium. Sodium is an alkali metal. It's a group 1 metal, so it's +1. And oxygen is going to be -2. And then sodium over here by itself is in its elemental form, so it's going to have an oxidation state of 0. And that is going to be the same for oxygen over here by itself. All right, so now what we want to do is we want to look and see where some changes have occurred from the reactant side to the product side. And I can clearly see that sodium went from a +1 ion to a neutral atom of sodium. And oxygen went from a -2 ion to a neutral atom of oxygen. All right, and now I need to identify what's being oxidized and what's being reduced. And the easiest way to do that is think if the charge goes down, it's reduction. And the only one where the charge went down was for sodium. So sodium went from a +1 down to 0. So this is going to be reduction up here. And then oxidation is going to have to be the other one. All right, and for this particular compound, let's go ahead and do what we've been doing with the other ones. So I've got oxygen, which is being oxidized, meaning it's losing electrons. So I'm going to draw the little arrow away from oxygen, and those electrons are being picked up by sodium. All right, and so if we think about it like this, oxygen is giving away electrons to sodium, and when it does that, it's causing the reduction of sodium. So oxygen is causing sodium to become reduced, but in turn, when sodium accepts those electrons from oxygen, it takes them in, it is causing the oxidation of oxygen. All right, so they're doing this to each other. And if we take a look over here at our reactant side, we've only got one reactant and it contains both of those. So this is going to be both the oxidizing and reducing agent. All right. All right, so now that we've done that, let's go ahead and start writing our half reactions. So we did say that oxygen was the element that was oxidized here. So I'm going to start with what's on the reactant side for oxygen. I have oxygen with a -2 oxidation state. And because oxidation shows how electrons are lost, I know that the electrons are going to have to be listed separately from this oxygen that I started with, because this oxygen is going to be losing those electrons. And when it does that, it becomes elemental oxygen and 2 electrons. Because I know this oxygen had to have lost 2 electrons in order to go from a -2 oxidation state to a neutral atom of oxygen at 0. All right, so this is showing the loss of 2 electrons from this oxygen. So now what I want to do is I want to write the reduction half of this reaction. And so again, since sodium was reduced, I'm going to start with sodium on the reactant side. So I've got sodium +1 ions. And this time, because it's undergoing reduction, we know that the electrons are added into that in order to reduce it. So we have to add the electrons on the reactant side. So I'm going to add 1 electron here. And sodium is reduced to a neutral sodium atom from a +1 ion to a neutral sodium atom by the addition of an electron. All right, so now that we have both our oxidation and our reduction half reactions written out, we want to take a closer look at them, and we want to make sure that they are balanced for the number of electrons that are going out of oxygen and into sodium. So if each oxygen atom is losing 2 electrons and each sodium atom is only gaining 1 electron, we have to account for a proper number of sodium atoms to be able to absorb all of those electrons. And so what we end up doing is we multiply everything in this reduction half reaction for this particular example by 2, because we need to show that there are 2 electrons coming out of oxygen, but also 2 electrons being taken up by those sodium atoms. So we're balancing this by multiplying everything in the sodium half reaction by 2. So I end up with 2 sodium ions plus 2 electrons yields 2 neutral sodium atoms. And then I don't need this anymore, so I'm just going to cross that out. And now what I need to do is I need to combine both the oxidation half reaction and the reduction half reaction back into a single reaction. So I'm going to do this by taking all of the reactants and listing them first on the reactant side. So I have oxygen -2 ions plus 2 sodium ions plus 2 electrons. And that is yielding. And then the next thing I'm going to do is I'm going to write all the reactants on the other side. 1 neutral oxygen atom plus 2 electrons plus 2 neutral sodium atoms. All right. And then my last step is to go through this reaction and cancel out anything that shows up on both sides. And for this, the only thing that's going to show up on both sides here are the electrons. Assuming that we had them balanced properly, they should be equal to the electrons on either side. And then we end up with our overall balanced redox equation of oxygen -2 plus 2 sodium +1 ions, and then a neutral oxygen plus 2 neutral sodium atoms. So here's my balanced redox equation for this problem, right? Balanced for charge. All right. So let's go ahead and take a look at one more example. So in this example, I've got tin 2 chloride reacting with iron 3 chloride to produce tin 4 chloride and iron 2 chloride, right? Lots of chlorides in here. So the first thing I need to do is I need to go through and assign oxidation numbers to all of the elements in this equation. So chlorine is -1. There are 2 of those, so tin is going to have to be a +2 in order to balance that out. Chlorine here is -1, and there are 3 chlorines here, so there's going to have to be a +3 on this iron to balance that out. Chlorine again, -1. There are 4, so tin is going to have to be +4 to balance that out. And then chlorine again here is -1, and there are 2 of those, so iron is going to have to be a +2 to balance that out. All right, so now I need to go through and I need to look for what changed or what the differences are from side to side. And it looks like I have tin going from a +2 to a +4, and I have iron going from a +3 to a +2. All right, now the job is to identify what's been oxidized and what's being reduced. And I think the easiest thing to see is what's being reduced, because the charge goes down from one side to the other. And iron here goes from a +3 down to a +2, so this is going to be reduction. All right, and then the other one is going to have to be our oxidation. All right, and so since we said tin here is being oxidized, that means it's losing electrons, and iron is gaining those electrons. And so when tin gives electrons to iron, it's causing the reduction of iron. So this right here, this tin chloride compound, is going to be our reducing agent because it's causing the reduction of iron. All right, and then in turn, when iron takes those electrons from tin, it's causing the oxidation of tin. And so this iron-containing compound in our reactants is going to be our oxidizing agent. All right, so there's that. So now let's go ahead and write our half reactions. So the first half reaction we were going to work on is our oxidation half reaction, and we did say that tin was oxidized. So we're going to start with tin. And tin is SN plus 2 on the reactant side. And it's going to lose electrons because it is being oxidized. And so we show what happens to tin afterwards. We have SN plus 4. And in order for tin to have gone from a +2 ion to a +4 ion, it would need to have lost 2 electrons. All right. And now we need to talk about the reduction half reaction. So we said that iron was reduced. So we're going to start with iron plus 3. And when something becomes reduced, it's because it has pulled in electrons. And so we're going to write those electrons on the reactant side. And iron went from a +3 to a +2 ion. And in order for that to happen, we would have had to add 1 electron in there. All right. So what we've got is something similar to what we saw in the last example. We have tin getting rid of 2 electrons and iron atoms only pulling in 1 electron each. And so we have to balance this for the number of electrons that are being let go by tin. And so we just need to have the same number of electrons in both reactions. And the easiest way to do that is to multiply the second reaction by 2 this time. And it is worth noting again that you might not always be multiplying this by 2. It could be multiplying it by another number. Sometimes you might be multiplying your oxidation half reaction instead of your reduction half reaction. And there will be other times when you might have to multiply both reactions by something in order to get the number of electrons to be equal. You just want to make sure that whatever you're multiplying them by is the smallest numbers you can multiply them by to get those electrons equal. All right, and so after we multiply this out, we get 2Fe plus 3 and, 2 electrons, and then 2Fe plus 2 ions. And then we're done with this. All right, and then the last thing is for us to just go ahead and combine these back together. And so I'm going to take all of my reactants and list them first. So I've got Sn plus 2 plus 2Fe plus 3 and 2 electrons. And then I've got all of my products. So then I've got Sn plus 4 plus 2 electrons plus 2 iron 2 ions. All right, and then last, I need to cancel out the electrons that show up on both sides. They have to be equal for me to be able to cancel those out. So then I end up with 10 plus 2 and 2 iron 3 ions, and then 10 plus 4 and 2 iron 2 ions. And there's my balanced for charge reaction for this problem. All right, hopefully this was helpful. If you have any questions, please go ahead and let me know. You can come see me during tutorials or you can ask during class. I will see you guys then.